Well, howdy, physics sleuths and inquisitive souls, and welcome again to another lecture of dynamic gravity. So, this lecture, I'm going to go over the results what I've learned so far about my anti-gravity experiment that I've been running for like the last been a while. Been at least a good year I've been working on this, trying to figure a way to make it work. And the fact that I haven't released anything in that year shows you I really haven't discovered a whole lot that I would claim remarkable. Thomas Edison said, how to figure out how to make a light bulb or not make a light bulb 900 times. Well, I figured out how to make a light bulb. That's the way it goes. Science by trial and error. Isn't it wonderful? So, what we're trying to do here is the goal of dynamic gravity, the holy grail, is to make a gravnetic field. Okay? And a gravnetic field is essentially, let's see, what is this? This was something I was messing around with, trying to improve sails on boats, just mess around with laws of physics. Nothing that we need to be concerned about, kids. Okay. So, when you have a electron, it is constantly pumping out an electric field. It is an electric field. But it's in the form of a vortex. That's how it's stable. That's how it's keeping itself together. It's a vortex that's folding in on itself, that's constantly renewing itself as it does this through like the right-hand rules and all this stuff. All right? That's how you make an electric field. And if you were to take this and move it, bloop, 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 now what you've done is create a magnetic field. Okay? Electric field, static. Magnetic field is an electric field that's in motion, okay? And you see all the wonderful things we can do with magnetic fields these days. So, according to my theory of gravity, dynamic gravity, which is correct, and if you doubt, well, I would like to see your math, sir. I'm the only human being that ever lived that can perfectly calculate gravity, dark matter, and dark energy with all observations ever with the same equation. Something you might want to consider before you say, I'm bullshit and I don't know what I'm talking about. But anyways, according to my theory, if you have a cork, okay, cork, Q, it is constantly emitting its cork field. Now this is not the positive part of an electric field. It's not like the electric field is negative and the cork is positive. Although technically it kind of is, but that's the way modern science wants you to think of it. Negative electric field, positive electric field. But that's not true. What is actually in the cork, what it's made of, and what it's emitting is gravity. It's a gravity field. It's a gravity field. And what we've learned, when we move the electric field, we get a magnetic field. So, according to my theory, when you move a cork around, bloop, 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 and its positive charge, you get a totally new thing. It behaves similar to a magnetic field, but it's completely different beast. It's not made of like the electric field in motion. It's made of a gravitational field in motion. So that causes a whole different beast that you've just created. And this is essentially how anti-gravity is going to have to be made. You're going to have to get somehow the positive part of the field, the gravitational field, and it's going to have to be in motion. Unless you can just, find a way to create and destroy a bunch of corks. That'll work too. I'll go into that later. But yeah, this is the main reason. We want to try and simulate a magnetic field only for gravity. kind of what the aliens can do. And this is the overall principle of what's going on here, essentially, in a lot of ways. Now, that's not how their reactors work. I'm going to explain that in this video later on, this little tidbit for you. But no, this is a really good thing. This is our goal as humans to strive for. They're beyond this. This is what we just want to create a gravnetic field. Then we'll have anti-gravity. Won't be very strong, but it will be there. It'll be present. All right? So that's what I've been trying to do. I've been trying to devise an experiment where I can somehow take advantage of a situation where I can access the positive part of the quark and somehow get it in motion or something, get it to do something. Just trying to get something going. That's all I'm trying to do, all right? So what I've done is, let's start at the beginning, shall we? Okay. Oh, but why is it? Man, that doesn't look good. Huh. That's really weird. Maybe the aspect is off. That's what it probably is. The aspect is off. We can fix that. I can fix that. I was a techno geek for a long time, children. Don't worry. I can fix many things. Many things I can fix. That's what I do. I'm a fixer. You break it, I fix it. That's our relationship. Okay. So, what we've got here is I have a electrode, right? And I'm running high voltage, both AC and DC, both experiments. And what I'm trying to do is to create a spark, all right? Now, technically what a spark is it's the ionization of atmospheric particles, all right? It's ripping off the electron, and that's making a positive ion. And this is essentially kind of what the beam is made of an electric spark, all right, is a bunch of ionized particles, like gas particles, okay, that are become electrically conductive. Now, this seems like it'd be a good place to look because we know we've got positive ions being created and they're in motion, right? Now, will a positive ion by itself create a gravnetic field? Maybe. Depends on the ion, depends on the circumstances. You have to remember there's a whole lot of electrons at play in there neutralizing it in that atom, unless we're talking about helium or about hydrogen missing its electron. Now we have an unpaired proton. That's what we really want, but that's really, really hard to get. Helium gas probably be the best to conduct this experiment and not nitrogen, which I've been doing, but I don't have access to that yet, so hydrogen gas. But then the hydrogen gas could be explosive, so who knows? It could be all sorts of crazy things, all right? But what we've got going on here, see the distortion, all the high energy electric fields, magnetic fields bombarding the camera. That's why it's going in and out. Like that. Okay? Now, so this is what we're looking at, this spark. And we're trying to see if we can measure anything coming from this spark that's not a magnetic or electric field. Okay? So, that was DC. This one is DC as well, but this is nighttime, so you can see how bright it is in regular atmospheric air. Okay? So, now let's begin the experiment. I had to devise a way to measure if there's any force at all being generated from this little circle coming through or out of it, all right? Now, I tried working eventually with scales and balances, seeing if I could do that, and I couldn't find any sort of setup that would work in a way that I could measure to the degree I needed to without knowing it was definitely going to be affected by everything else. It's just going to mess up. So what I decided to go with is like a thread, right? So I started with just a regular basic thread. So I've got my thread dangling here, just over the portal here. I've got a high electricity going through this electrode, this copper electrode, going towards this magnet. And then I've got a plastic shield that's a barrier in between this opening and this thing. Because when you ionize the air, what's going to happen is a high electric field like this, you're going to rip off all the air particles, electrons, in the electric field, and then they're going to be affected by the electric field massively. So they're just going to just go back and forth. So you're going to have a lot of electric wind, so to speak, that's going to be pushing stuff. That's not what we want to measure, okay? That's not what we want to measure. And so I'm trying to limit that every possible way that I can, okay? So I start off with this plastic barrier going in between. And you can see, even with the plastic barrier, there's no airflow going in between here. But yet, the string, so I touch that high electrode, touch it. So it's definitely being affected, okay? We're definitely generating force. But I'm not satisfied it's anything new that we should be concerned with at this point, all right? But you can see that there's definitely force being generated from this somehow, even though there's a plastic barrier separating this, okay? So, my bad. I think I don't have a plastic barrier on this. Maybe the other one I think I did, but this one I think I don't, all right? And now I started off with string, like thread, because it's very light and it will move a whole lot with very little force. So I've been able to devise a way to measure how much force, even though it's incredibly small, that's coming from this device, all right? But as we can see, there's no barrier here. We know we got a bunch of ionic wind just being pushed through here, so that's definitely going to be affecting that, okay? So we're going to try and see if we can't nullify that. So I think now I have the barrier in between here. I think so. Maybe not on this one. Yeah, I think I can see the shine. The barrier is definitely there, okay? Now we're looking at this barrier, okay? And you can see it's still got movement. It's still moving, even with the barrier there. It's moving a lot less, but it's still movement. But still, the electric field generated from this and the sparks is very high. And anything that's going to be ionized is going to be drawn towards a magnet. It's going to interfere with our experiment. So I'm not satisfied by any measure yet that I've created any force. Okay, I only know that I'm generating something that I want to measure and find out, get to the bottom what it is. Okay, so that's what I did there. Here's another. You can see the barrier. Just another one. Bam. This is AC. The other one was DC. It has a lot more louder pop to it. This is the AC. It's got like a squelch to it. And I want to see if there's a difference between the force that AC and DC can pit out. And I did notice DC for the same voltage, like around 20,000 volts, like 20 kilovolts. The DC is definitely affecting it more. I mean, the AC does affect it, but it's very little, as you can see. It's not as much. So I focused mainly on DC after seeing how poor the AC does compared to DC. Could be different reasons for that. I don't know. I'm not going to speculate just yet, but it appears DC generates more force than AC, right? So now I'm doing this experiment in all different ways, different electricity types, everything. There's AC again. And you can see it's really not moving a whole lot. In fact, now that I measure this, yeah, you see it does move a little bit. It is moving a little bit. You can see it's moving a little bit, but barely. So I've got I've got my windshield here to protect me from the ionic winds, and even with AC, I'm still getting movement, okay? So we're going to dig deeper. We're going to dig deeper and see if we can't do better science, okay? So what I've done here, did I do it on this one? No, I didn't do it on this one, yeah. Okay, but this one, what I've started to do is I took away the shield here and I pit it on the backside, okay? So this is now completely airtight. I've got it glued on there. It's airtight. There's no air that's going to be coming through and through this at all now, okay? So let's see what it does now. Okay, even with this back shield blocking all the airflow that I have here, it's just a plastic container. We still have movement, and that's with the AC, so that's really good. It's not a whole lot, but there is something there. But once again, we got high voltages coming around here. Air is going to get aionized, so the only way to truly conduct this experiment is in the back. Next. So, first I decide, okay, how can I test whether or not these strings that I'm using, like just a thread or a piece of glue, are not being affected by this massive electric field that's being generated by it as well, okay? So, I get a Tesla coil, all right? And here's what I'm gonna do. This is the glue, a string of glue that I made, and we're gonna see if it's affected by the massive electric field of this Tesla coil. And you can see it is absolutely moving and being drawn to the Tesla coil. So I believe the electric field is still somehow charging this long bit of glue that I have, the string of glue. Even though it's glue, molecularly it has imbalances in there on a very atomic level that could still allow it to be affected by an electric field. Charge up, static charge, whatever. And we see it's definitely doing that, but very little, okay? Now, here's another Tesla coil. Yeah, this is a Tesla, no, there's a Tesla coil. Here is a Tesla something. It's basically what I've made, only this is kind of a different version of it, a more better made version, I guess you could say. So we'll take a look here. Yeah, look at that. Even this far away, when I turn on this Tesla coil, it's still moving this string. Look at how far away it is. And it's still being affected by this electric field. It's really crazy. So it's definitely 100% being affected by an electric field. Okay? And here is the test with a string, right? We did a thread of glue. Now we're doing a thread, just a common thread you used to sew because it's so small and light. I thought it might work good. But as you can see, look at how much that one gets pulled. Like the string gets pulled a little bit. This one gets pulled a lot. So at this point, I pretty much have abandoned all the threads because it's affected by an electric field. So what I did then at this point, this was probably about 8 months ago that I was out here, at least 6. So what I decided to do at this point, okay, here's the other Tesla thing. That's basically what I made, only this one's a better version because mine, what it's trying to do is I want to make a spark, and then this spark, due to the electric or the magnetic field, is forced a certain direction. But when it goes really, really fast, it looks like it's all just one wall of electricity. But you can see it's just one thread of electricity to plasma that's just constantly spinning around, okay? So what do we have? We have, like I said, our spark, but it's in motion and it's going really fast. As you can see, so fast our eye can't even track it. So my goal is I'm hoping that maybe the ionized air is what's actually being dragged by the magnetic field around in a circle, okay? And if that's happening, then we have a positive charge, a positive, a bit of gas that is now being pulled very rapidly in a circle very quickly. This is exactly what we want to do to make a gravnetic field. This is 100% it. My experiment kind of failed because I wanted it to make a continuous circle like a proper one does here, but I don't have it engineered well enough to do that. And so it's just going to the shortest path and just making 1 volt of plasma charge. It's not really moving around a whole lot what I want it to do. So I might have to start banning all of it and trying to use this somehow, but this is the problem, okay? As you can see, this is definitely pulling very hard on the thread of glue. This is a thread of glue right here, which is the least thing I could find that was affected by electric field. I tested a whole bunch of components. That's what I'm trying to do, like little pieces of paper, cutting up little strips of everything, anything that's small, thin, and light. You know, I've been trying to test different things that aren't affected by a static electric field. Because if I can find something that's not affected at all by an electric field, but yet still moves like this in a vacuum chamber, then I might actually have succeeded on what I want to do. But I'm not there yet. I'm not there yet, okay? We have this. So here's my final test, all right? Here's my vacuum chamber. Yes, my dirty room. So I got electronic components laying all over the floor. I'm a horrible geek like that. That's what I do. Okay, so here's my vacuum chamber I've got now, okay? Had to do some finagling, get high voltage into this bad boy. Like the first one I got, I tried to drill a hole in, and as I did that, the entire thing imploded and shattered to a billion pieces. I had to pick up all the glass, and it sliced me up. It was so much fun. I loved it. Recommend 10 out of 10. Yay. So I had to get a whole new setup and figure out a whole new way how to run high voltage probes into my vacuum chamber, okay? And this is very dangerous, just so you know. If you do high voltage in a vacuum chamber, usually you're making x-rays. So you don't want to just do this willy-nilly, boys. I don't want to say I'm a trained professional, but I'm a little cray-cray, all right? And I at least understand the danger that I'm facing. You probably don't. You probably don't want to do this, all right? But here's my vacuum chamber, and you can see I've got it, pulled out to pretty much the maximum, which is like, I don't know, it's probably going to be like 5% of what air is. It's not going to be a perfect vacuum, but it's going to take out like a good 95% of that air. It's going to take out a lot. And that's going to do multiple things. There's going to be a lot less air that's going to be ionized, allowing the plasma to create itself a lot easier with less energy and be a lot more sustained. But also you're going to have a lot less air that's going to be swooshing and being dragged around by the electric field that's going to be ionized, that's going to be moving your part. So I would like to have a perfect vacuum ideally, but that's super, super hard to get. But this isn't a vacuum chamber, okay? And we can see here's my high energy electrode right here. I got DC running into it. I got 2 little thin. I ended up using zip ties. They got like metal zip ties, but they're really thin. So I put 2 of them, one on each side. And you got to push down a little bit when you do the vacuum, or sometimes it'll mess it up. Or put like a little oil on top, get a good seal. But I noticed you have like just 2 metal zip ties. You can attach electrodes to them, and now you can run high electricity into your vacuum chamber to do all sorts of dangerous things like make x-rays and blah blah blah. Okay. So that's what I did. All right. So now when I turn this on, here's a powerful magnet I have right here, and here is my thread of I think it's glue, maybe this one's paper, I'm not sure yet, dangling down right by this. And so when this goes, I want to see if there's any movement at all from this thread now that we're in a vacuum chamber. Okay. So there's my thing. See, I'm not getting a good circular spin like I want to, but I guess I'm just bad at engineering this sort of stuff. Everything I tried failed miserably, so. I think right now I'm trying to get the focus on the thread right here so you can see it move. Come on, Sean, you can do it. There we go. Yeah. Okay, you see that? You see that thread move? Blah, blah. It went blah, blah. And it did it like in a movement, which was weird, like goop, goop, like as the device is being turned on, which is really weird because I'm expecting more of a flowy movement, but it's more of like a which kind of tells me it's probably more static electricity than anything. Okay. But I'm trying, is where I'm at. I'm trying to measure whatever I can and hopefully find a material that's not affected by static electricity that's going to be created from, this large electric field. See my electrodes I got up here, I got running a high voltage into it, my zip ties. But you see, even the vacuum chamber, even with, I think this is the glue, we are still getting movement, okay? We're still getting movement. This is definitely not ionic winds. This is not the electric winds that are pushing it to this degree. It's definitely not that. So we've ruled out the winds a lot. It is still affected by force from this device in a vacuum, and you can tell the way it's moving is not winds, okay? But here I'm gonna release the air, release the vacuum, let it go down to, I think this is like 1 bar right here, the atmospheric pressure. So we're gonna release all that. And now you can see, now that there is air in this, atmospheric air, look at how much it moves now. Look at that, all over the place. All over the place. Total different beast. So, but it's moving so much with the air that even though we only have 5% of the air in there, that could still be, tripping it up easily. Easily, okay? So I did one final test, right? I got a thing in here, and as you can see, as I'm charging this up, this is just a long thread of something, paper, something, look at it. And the way that it moves, the way that it gets locked into place, and then after it shuts off for a second, you can see it takes time for that charge that's built up, that charge electricity on the string, creating an electric field around it to dissipate, and then it flips back. So this is when I think it got too close and it burned up, unfortunately. The one before really showed it great. But to me, this is proof that the electric field is 100% affecting a lot of stuff here. Like I can't trust this as my instrument device to measure force because it is so affected by the electric field that it's just being snapped into a completely different location when the electric field is present. All right, so we'll do it one more time. As it charges it up, whoop, sticks to it. Sticks to it. And then when I take it off and uncharges, plops down. Total electric field. So, what we've got is a problem. I have to find I have to either find a way to put this device into my vacuum chamber, which is small enough, I might be able to do that. And then that will give us optimal plasma, positive plasma flow is what I'm looking for. So I'm going to redo it all with this and see if I can't get better results. But the biggest problem that I'm trying to find right now that I've been on for the last 6 months is I'll just go through like the local hardware store, just grabbing all sorts of random stuff. And I'm trying to find something that I can use as my measurement device that is not affected by an electric field. And that is turning very, very hard. I'm sure there's got to be something, some material out there that I can get my hands on that just is not affected by an electric field. But until I find that and get my hands on it and throw it in my apparatus and find a way to fit this bad boy in the vacuum chamber, which I think it'll fit. It's about the size, but it's going to be close fit. We'll see. We'll see. So I'm not going to say that this experiment is a failure yet. It's inconclusive at this point. I haven't adequately gone all the way down through this rabbit hole, but it sucks. This rabbit hole is garbage. There is so many other forces at play here that I'm trying to nullify and to account for that are so powerful compared to what I'm trying to do, what I'm trying to measure. I don't know, boys. I don't know. This one's a tall order, but you know me. I'm stubborn like that. I don't give up so easy. If I did, I never would have figured out the math. Funny story about how I figured that out. All hard work and perseverance. A little guidance from God. But that's where we're at right now. This is the experiment. I'm not going to call it a complete failure, but I will say this. I have not seen anything that gets me excited yet. And so that's why I've been dragging my feet showing you this, guys, this experiment that I've been working on over the last year, because I'm lazy. It's hard to get me motivated. I don't have anybody to help me. And at the end of the day, I haven't found anything that I think is worthy. But I have spent a year on this, so I'm going to make a video of it and show you where I'm at and where I'm going to try and go next. Another thing that I really want to try and do is, while I have like an electric field present lighting up gas in the plasma, I want to put it on like a drill and just spin it super fast and then see it interact with other fields that are also going super fast and see if I can get any sort of measurement that way. But once again, that would have to be in the vacuum chamber because we can't have any air. Otherwise, the experiment is going to be a total flop. And it's hard to get a drill in the vacuum chamber. I've been looking for like children's toys, something small that will fit in there, and I can't find anything yet. But I haven't given up yet. All right. So that's the dealio. Now, for those of y'all that made it this far, I told you I would tell you how the alien spaceships work with their gravity, how they generate gravity according to my theory, okay? Now, I did a video on this 2 years ago before I figured out everything, okay? I told you I was working on it and I hadn't figured everything out. I now have figured out everything as of like a year ago, okay? I know exactly what all matter is, how it's created, antimatter, neutrinos, quarks, you name it, everything, how it's all made and destroyed, okay? And what we got is, if you want to know how the alien spaceships create gravity, I will tell you, okay? So, Bob Lazar worked at these from Area 51, and he didn't really figure out a whole lot, but one of the things he did figure out is that gravity is being generated, anti-gravity is being generated in the generator of the craft somehow, and that there is a lot of massive amount of anti-gravity in that bad boy for some reason. And they're like, well, it's just there to create energy somehow. When it comes to God, the aliens, usually it's a threefold thing, okay? Usually it's three separate things converging to one to make it super efficient and synergistic, okay? So yes, it is creating lots amounts of electricity, but hear me out. According to my theory, what we've got is we don't care about electrons, okay? Electrons are just made of electric fields. That's it. So if we mess with them, all we're going to get is the electric field. Lots of electricity, okay? But the quark, however, as we've gone over, is made of gravity, okay? An up quark, not a down quark. An up quark. It's just pure quark. It's just pure gravity being held together by motion of a vortex creating a gravnetic field, okay? So it's emitting gravity, and it's all made of gravity, okay? It's all gravity swirling on itself in the form of a vortex, okay? That's what it is, all right? Now, if we make antimatter, which I believe it is possible to make antimatter, but is beyond our abilities because the way antimatter for a quark is going to be made is within the nucleus of an atom that's under incredible energy and stress, okay? That's one of the ways that you make antimatter. So this generator is making antimatter. I don't know how it's making antimatter, but I know it's possible to make antimatter. It's not just a thing that's where you can make it if you have enough energy. Okay, so we have an antiquark. Okay, we have an antiquark. Bloop. And then, as Bob Lazar would said, it shoots a proton. It's like a proton accelerator in the base. It shoots a proton, a regular atom. Okay, but it could be antimatter. Who knows what they got? But it's one or the other. Okay, either there's antimatter in the chamber, like Bob Lazar says there is, and it's shooting a proton into that antimatter, or it's matter in the chamber and it's shooting antimatter at it. Either which way, it's the same thing. You have matter and antimatter that collide, okay? So, what have you got? You've got two particles that are entirely made of gravity, okay? That are held together by a vortex motion creating gravnetic fields, all right? Now, these two particles, though, are exact opposites as far as energy conservation is concerned, okay? So when they touch, pow, they make big boom and they dissolve, they destroy the gravnetic field that is making that particle stable and holding it together. So it destroys it, and now what you're left with is this release of massive amount of energy, okay? Now, that energy, it depends on what you're combining, what the antimatter and matter is. Depends on what the particle's made of, on what the energy you're going to come out. But if you were to take a quark and an antiquark and crash them together, the energy, the massive amount of energy it's going to be released is you have this is made of gravity being held by a gravnetic field, and this is made of gravity being held by a gravnetic field. Although one is positive, one is a negative. Let's not go into that yet. That's a whole nother level that we're not ready for. Let's just keep it simple. Made of gravity, held by a gravnetic field. Made of gravity, held by a gravnetic field. They combine. The gravnetic field becomes unstable and cannot contain the gravity it is containing anymore. What happens? Release, a massive release of pure gravity energy. Not a gravnetic field, but pure gravity. Because keep in mind, the gravnetic field is what's being destroyed, so that the pure gravity that is containing can now be released. All right? And this is happening beep, 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 billion times a second in the nuclear reactor. So it's just constantly releasing these pulses of large explosions of gravitational energy that's being pushed out. And then that gravitational energy is being siphoned through a waveguide, as Bob Lazar said, down to the gravitational amplifiers where it's being finagled with to get it more into a gravnetic field, I guess, to do things with. However, all sorts of crazy things to be going on with those amplifiers. I have to take apart. So, okay. So that's basically where the source of gravity is coming from for an alien spaceship. The ultimate source and the reactor, like Bob Lazar says. It really is what he says, but they didn't understand it because they didn't understand what matter is and what it's made of and how it's all held together like I do. So that's where the gravity is coming from with the alien spaceships, okay? When you combine quark and anti-quark together, you get pure gravity as the explosion of energy that's released. Gravity which you can then harness and what just like you can guide electricity, right? Or even an electric field with magnets and conductors and all this stuff that will dissipate and transfer that energy. You can also do that theoretically with gravity because just as you can do for the electron, you can also do for the quark. But now we're in a whole different realm because we have to have completely different characteristics of matter to be able to do that because matter has the positive part on the inside surrounded by the negative electric shield of the electron. So it's very easy to make electricity conduct or an electric field because it's the outside of the atom. It's the lowest part to push. But if you're going to do that and have like a waveguide for gravity, now you have to have some sort of matter that has the reverse characteristics. Instead of it being good at conducting electricity, now it has to be like almost flipped inside out, the atom, to be good at conducting gravity or a gravnetic field. And our science is not there yet. It's not even close. We are so far behind on the materials to even begin to see that. Even if I live to be 100 and people start taking my theory serious today, I don't think I would live long enough to see that come to fruition. But it is possible. It can't be done. Every time we see a flying saucer, it reminds us it has been done. You just haven't figured it out yet. Sorry. So sorry. Not sorry. So, there we go. I think I've done a good job on explaining to you guys this whole situation, what's going on, blah, 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 blah. I'm still going to keep beating away at this Gravnetic field experiment as time goes on, but we're running out of time. If you follow my channel, then you're aware. I personally believe we are in the final year of the Great Tribulation. I believe that it ends with Putin nuking all NATO countries, sending the entire world into a 5-month-long nuclear winter, killing 2/3 of the planet. And I believe that is going to happen probably around October or November of 2026, but it could be as early as April 2026, depending on how God wants to start the clock of the Great Tribulation. It's 7 years to the day. So if we know the day that God started the tribulation, we know the day that it will end, and hence the day that Putin will nuke the world. All I can tell you is it looks to me like a 95% chance it is definitely going to be between April and November of 2026. I would wait to see the results before you declare me crazy, little one. Many people have betted against me in my lifetime, and no one ever made a dime from it. But I'll catch you gentlemen later, and we'll probably dwell deeper into the realm of God, because, yeah, I love science. I love all of that stuff. It's great too, but you know what? God is amazing too, and he deserves just as much love and credit as science does. So I try and give them all both, all my love. I love them both, all of them, forever and ever and ever, and ever and ever and ever, and ever and ever and ever.
Like, subscribe, submit.